Welcome you all to a new session. In this session we are going to see conversion of one flip-flop to other type of flip-flop. In the previous sessions we have already seen the flip-flops, like different types of flip-flops like SR flip-flop, D flip-flop, JK flip-flop, T flip-flop. In this session purely we are considering how to convert one form of flip-flop to other form. For example, if I want to convert SR to D or JK to T or D to SR, anyway I need to follow few steps. Using those steps you can convert one form of flip-flop to other type of flip-flop. Let us see an example here. I want to convert here a JK flip-flop. A JK flip-flop need to be converted to D flip-flop here. I wanted to convert JK flip-flop to D flip-flop. Now we observe. Now with the help of question itself, I can come to a prediction that this is, with the help of question, this is my converting JK flip-flop to D flip-flop. With the question, my available flip-flop is JK flip-flop and the required flip-flop is D flip-flop, right? With the help of question itself, I can tell that I am having JK flip-flop and I need a D flip-flop. So I am writing two things. I am writing my available flip-flop as JK flip-flop and I am writing my required flip-flop as D flip-flop. Two things we have notified using question itself. Now, once after writing it, I need to get my required flip-flop characteristic table. I need to get my characteristic table for my required flip-flop. Now, what is the required flip-flop here? It is D flip-flop, right? So, for D flip-flop, you know the characteristic table. So, D, Qn, Qn plus 1. So, that is D can take either 0 value or 1 value with the present state as 0 or 1, with D as input 1 with present state as 0 or 1. Now when 0 is presented as input for my D flip-flop, irrespective of my present state, this is my present state, right? Qn is my present state, Qn plus 1 is my next state. Now irrespective of my present state, my next state is always 0, that is reset state. That is, if I am providing 0 as input, it is going to produce 0 as my output, right? Next, if I am having 1 as my input, then my next state is always 1. This characteristic table has to be written for our required flip-flop. Now once characteristic table is written for our required thing, next I need to write the excitation table for my available flip-flop. What is available flip-flop? My JK flip-flop. Now I am writing my excitation table for my available flip-flop, that is JK flip-flop. Excitation table means I need to observe my outputs through inputs. Means I am going from outside world to inside world, I am going to observe it. Now you can see Qn, Qn plus 1 are two outputs which I am going to consider as inputs in this table case, in this case of table, and J and K as my output values. Now Qn, Qn plus 1, that is 0, 0, 0, 1, 1, 0, 1, 1. Now you know the excitation table for JK flip-flop. My outputs are 0, 1, don't care, and K values as don't care, 1, 0. Means this order should be always in opposite to the order of this thing, right? That is what I taught you in the previous sessions also, that order of J should be in reverse order to that of K. So this is your excitation table. Now while converting from JK flip-flop to D flip-flop, two things we were identified, that is available flip-flop, required flip-flop. Now available flip-flop, I am making a characteristic table, and for available flip-flop I am making a excitation table. Now using these two tables, we need to get one more table. That table we call it as a table extension. How we are doing table extension? Table extension is done based upon my characteristic table as well as excitation table. Now combining these two tables, I need to get my third table. That third table I am going to call it as an excitation table. Now see here, this is a table extension which I have made based upon my characteristic table and excitation table. Now if you observe, I have taken D, Qn, Qn plus 1. D, Qn, Qn plus 1. So same as it is values of my this particular characteristic table I have depicted onto this particular table. Now if you observe 0 0 0, I have written 0 0 0, right? Next 0 1 0, 0 1 0, same values. Next 1 0 1, 1 0 1, same value. 1 1 1, 1 1 1, I mentioned here, right? So all the values has been mentioned here. My last thing. Now you got this particular table, but you need J and K values as output values. J and K as output values. Now what values will be there for? Here I need to observe this middle values, that is my present state and next state values I need to observe here. Now my present state, this is my present state, this is my next state, right? Now these two columns I need to observe from here, and I need to get J and K values from my excitation table. Now if you observe 0 0, Qn and Qn plus 1, that is present state and next state is 0 and 0. If you see here, 0 and 0 is giving me 0 and don't care. So I am writing 0 and don't care. My first value I have obtained it, right? Next 1 0, 1 and 0 is giving me don't care and 1. So I am writing don't care and 1 here. Next 0 1, so 0 and 1, my J and K values are 1 and don't care. So I am writing 1 and don't care here. Next 1 and 1, 1 and 1 means don't care 0, I am writing don't care and 0 here, right? So you got a table extension based upon my characteristic table as well as excitation table. Now using this particular table, I need to get my Boolean expression for J value and K value. For two things I need to get the expression for J and K. Now if you observe, I got two input values, that is present state along with my input value. I need to get my J equation and K equation. For J, D as one input, Qn as the other input, 0 and 1, 0 1 1. Now if you see, observe my values 0 0 0 1. I am taking, I will represent it with a different color. I am just observing only these values. I am not considering my next state. Why? Because next state is something which is generated based upon my input and present state only. Next state is getting generated. That's the reason I am taking only D input along with my present state. So 0 0 value, J is giving me 0. So I am marked with 0. 0 1 is don't care. So I am don't. 0 and 1 don't care is I am marking with don't care. 1 and 0 is 1. 1 and 0 is 1. Next 1 and 1 it is don't care. 1 and 1 I am marked with don't care. Done. So you know the don't care condition, that I need to include the don't care condition along with my minterm so that I can get a minimized expression. So I am considering 1 and don't care as one group. So J is equal to, what is the left side's common thing? That is D value. This is D bar, this is D. So J is equal to D is the Boolean expression for J. Now coming to K. K I have taken D and Qn 0 1 0 1. Now 0 0 value is don't care. So I have marked don't care here. 0 and 1 is 1. Is 1 I have marked here. 1 and 0 is don't care. I have marked don't care here. 1 and 1 is 0. So 1 and 1 0 I have marked here. So I have taken this minterm along with my don't care. I have grouped it as a group here. So my expression for K will be, on the left side you can see it's D bar, it's D. So my K value becomes D bar. So I got two expressions, J is equal to D and K is equal to D bar. Now using these two expressions, I need to draw a block diagram representing the conversion from one form to other form. Let us see that one. Now this is the block diagram where you can see this is a JK flip-flop, and I got my expressions as J is equal to D and K is equal to D bar, right? Two things I got. Now J is equal to D means at the data D means I have connected my D value as it is, right? And K is equal to D bar. I have connected through a inverter to K value. So K is equal to D bar. Along with that I am providing a clock. Why? Because clock has to be in sync with my input values. So inputs will go in sync with clock, then it is going to produce the output Q and Q bar, right? So this is how you can see, observe a D flip-flop, a JK flip-flop converted to D, right? So that's the reason the same procedure has to be implemented for any kind of conversion from one form of flip-flop to the other form of flip-flop. Same steps needs to be implemented for any kind of conversions. So in the previous question papers, we have seen the conversions from SR to JK, JK to T, D to SR, SR to T. So those kind of conversions were asked. So based upon only three tables, you need to come to the conclusion. One is characteristic table, excitation table, table extension. Then derive the Boolean expression. Then after getting the Boolean expression, draw a block diagram. Okay. So this is what related to the conversion of flip-flops. Thank you one and all.